here is question 11. In triangle ABC, AB is C, BC is A, and AC is that whole long thing under the square root sign, and they want the angle. Obviously, you're going to need a diagram. So I've got my diagram here. I've labeled everything, and they've given that to you. Then they've said to you that you are supposed to find angle B. So there's angle B with a dot, and I've written out my formula. So angle B is going to be A squared plus C squared minus B squared over 2AC. And we know what B is. B is that long thing over there. So if I fill this in, I've got cosine B is equal to A squared plus C squared minus, and then this is B, A squared plus AC plus C squared squared over 2AC. Now the answer you have in your booklet is the same, except they haven't used this format of the formula. They've used the other format when you're looking for the sides. But frankly, this is definitely going to be easier. So this is A squared plus C squared. The square root and the square are going to cancel, so I'm going to have minus. Now you have to be a bit careful with the minus sign. A squared minus AC minus C squared. Right? The square root and the square are cancelling, and that minus belongs to everything. So I've got that over 2AC. So that one is going to cancel with that one's going to cancel with that one, and I've got minus AC over 2AC. So then that one's going to cancel with that one's going to cancel with that one, and what you have is you have cosine B is equal to negative a half. Now I'm hoping that you're at the sort of stage that you know that if it's a negative number, it's going to be an obtuse angle, because as I said, cosine never lies, and if it was positive, it would give you an acute angle. Doesn't matter, your calculator knows. You're going to go shift cosine, put in the negative 0.5, and whoops, I put in the wrong angle, and then write down your angle, which is 120 degrees. So that should not be a problem, and your question is done. So that takes us to question 12. We've got two triangles where we've got two sides and an included angle, and it's screaming cosine. They've said theta, and they've said 180 degrees minus theta. So we're going to just do that as two simultaneous equations, because we can work out AB from the two things straight away. It says difficult, but it's not that difficult. So I'm going to actually just start it on this page over here. We can see that AB squared is going to be equal to A squared plus A squared minus 2A squared cosine theta, right? Two sides and the included angle for that triangle over there. And then we're going to do AB squared over here for this triangle, and it's going to be B squared plus B squared minus 2B squared cosine 180 degrees minus theta. Now again, I should really have given you a bit of extra information for this, because you guys don't know a huge amount at this point, and probably that's what was confusing here. These two things are obviously equal, so I'm just going to make them equal and just say A squared plus A squared is going to be 2A squared minus 2A cosine theta is equal to B squared plus B squared, which is 2B squared, minus 2B squared cosine of 180 degrees minus theta. Now that is a reduction. It is in your syllabus. You are supposed to know it. I have actually given it to you and we've discussed it, but you probably don't know it yet, and it's not the end of the world if you don't know it at this stage, but you will know it in the fairly near future, right? So you are supposed to know that cosine of 180 degrees minus theta is the same thing as negative cosine theta, okay? That's because this one's the acute angle, so you can imagine if I had cosine of 20, then if I say cosine of 180 minus 20, I have cosine 160, and they're the same, but one's positive and one's negative, which officially we know. And remind me to discuss this with you in class again tomorrow, just so it's a little bit easier. But for right now, we can just believe me and say that that is true. So now we have 2a squared minus 2a cosine theta. So I've got 2a squared minus 2a squared cosine theta is equal to 2b squared minus 2b squared cosine theta. And that is now positive because I've changed it from 180 degrees minus theta to just theta. And now we are just going to solve this and make this neater. They've asked us to find a over b. You can factorize this. So I can go 2a squared, and that's 1 minus cosine theta. And I can go to b squared, and that's 1 plus cosine theta. Okay, so that's a 1. And then we can divide both sides by 2b squared. So that one's 2b squared. So those cancel. And the 2 will cancel with that one. And we've got a squared over b squared is times by 1 minus cosine theta is equal to 1 plus cosine theta. So again, we can now divide both sides by 1 minus cosine theta so that we have a squared and b squared by themselves. And since we want a over b, that's obvious that we're going to go there. So I'm going to come back and do that later. I need more space. So I've got a squared over b squared, and then I've divided both sides by 1 minus cosine theta. So I've got 1 plus cosine theta over 1 minus cosine theta. Now, if you were really on top of it, you would have got that far and then probably got really confused about what on earth was happening. We need to have a over b. You cannot, if we have the square root of 1 plus cosine theta over 1 minus cosine theta, that is never going to get us to our proof. So we're going to have to do something else. So one of the techniques that we use in maths quite a lot is timesing by 1. So what we're going to do is we're going to times this by 1, which is 1 minus cosine theta over 1 minus cosine theta. And if you're thinking, how on earth would I know that I'm supposed to be doing this? Because there's nothing else you can do. There really isn't. So then you have to be able to think, well, there must be something I can do. If you multiply those out, you're going to get at the bottom 1 minus cosine theta squared. And at the top, you're going to get 1 minus cosine squared theta. In fact, let me just do it the long way and write it out. So I've got 1 times 1, which is obviously 1. Then I've got 1 times negative cosine theta, so that's negative cosine theta. Then I've got cosine theta times 1, so that's plus cosine theta. And lastly, I've got cosine theta times cosine theta, so that's negative cosine theta squared. So I've got a squared b squared over 1 minus cosine squared theta over 1 minus cosine theta squared, which are not the same things, you may notice. So we could square the a square, we could square root the a and the b and the bottom, but we still can't square root the top. And this is when you're going to use your trigonometric identity. And we know that sine squared theta plus cosine squared theta equals 1. Therefore, sine squared theta is equal to 1 minus cosine squared theta. My pen is not working very well. Okay, there we go. So I'm going to replace the 1 minus cosine squared theta with sine squared theta. And then at the bottom I've got 1 minus cosine theta squared. So now we can square root that and we can square root that. And we'll have a over b is equal to sine theta, because sine theta times sine theta is sine squared theta. And then over 1 minus cosine theta, which is what you were supposed to be proving. So some difficult algebra inside there, and some identities and some reductions that you don't know very well. Very, very difficult question. And if you understand any of it, then that's really very good. Then